Hi everybody. We're going to talk about chapter 18 now, which is a little more interesting. We're going to talk about probability models. And the first thing we're going to talk about is essentially some probability rules. And these can be found on the top of page 425 in your book. And the first rule, first of all, there's something wrong in your book. The probability of some event X or some outcome X actually can be 0 and it can be 1. Okay? Now typically it's between 0 and 1, but it actually can include the endpoints. For instance, if I select the name of the day of the week at random, what is the probability that it has a Y in it? Of course, it's 1. Okay? Let's see. And what is the probability that Thanksgiving in the United States is held on the 3rd Thursday in November? And that, of course, would be 0 because it's on the 4th Thursday in November in the United States. Okay? So, yes, probability can be 0. Probability can be 1. So, your book says it can never be at the endpoints. It actually can. The probability must be between 0 and 1, though. That's the important thing to remember. It can't be negative. It can't be greater than 1. Okay? Key elements. Now, if I add up all the outcomes for a particular experiment, if I add all those babies together, so I'm going to just use our favorite summation sign. If I add them all up, well, it will add to 1. So if you look at that example with they selected the young woman and they were looking to see if she were not married, and if they were to look at women who were select a woman, what is the probability that she is married or unmarried? It would be 1. Okay, you're either you're married or you're not married. Okay, and then finally, you have, or excuse me, one more. If you have a couple of outcomes, you can say 1 minus the probability of X will essentially give you the opposite. Okay? So whatever could that mean? So we saw in that example with the not married, the probability of not married was 0.506. Yes? Okay. So if I wanted to find out the probability, if I select a woman at random that she is married, oh, let me get my eraser. I think that's my eraser. Yeah, it is. Good. That she is married, then that's going to be 1 minus the probability of not married. And that's going to be 1 minus the probability that, excuse me, my fault. Goodness me. 1 minus the 0.506. And that's going to leave me with 0.494. Okay? And sometimes you'll hear that referred to as the complement. Not like when you tell somebody they look nice. Okay? But that's a real typical example. Okay? And then finally, I don't know if you're familiar with the concept of Venn diagrams. This is a Venn diagram. Okay, so in this particular case, I have A, I have B, and A and B have an excuse me, have a section in common. Okay, in this particular case, A and B don't have any section in common. So if I wanted to find the probability of A or B, it would simply be the probability of A plus the probability of B. I wouldn't have to worry about that flap. In that particular case, when I have the flap, I'll have to subtract it out. In the first case, the probability of A or B is the probability of A plus the probability of B, and then subtract out that extra flap, the probability of A and B. That's the shaded in region, because you've actually counted it twice. Okay? But in the second part, there's no flap, there's no overlap, they're distinct, so you only have to add the two sections together. Alright? Good. Okay. So, let's look at a couple of examples. Let's make up an example. If you look on page 427, the thing that says now it's your turn, and you have the dice. Let me change this here. And for our purposes, our dice are always going to be fair. And we want to find the probability that the sum of the dice is 7. So we think for a minute, and we think about, okay, when does that happen? Well, we know it happens when we have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. So we count up how many are those. 1, 2, 3, 4, 5, 6. So the probability of getting a sum that is equal to 7, sorry about that, it's equal to 7, is equal to, okay, 6 possibilities out of 36, and that's going to be 1 over 6. Okay? And then the next one says, what if it's a sum that is 11? And that can happen when we have 5 and 6, and when we have 6 and 5. Okay, those are the only 2 times it can happen. So the probability that the sum is 11 is 2 over 36, which is 1 over 18. Okay, now what if we want the sum equal to 7 or 11? Well, these don't have anything in common. Either it's a 7 or it's an 11, so we don't have to worry about an overlap. And that's going to be sum of 7 equal to 7 or 11. And I'm going to go back and put those back in the in the 36s. So I have 6 over 36 plus 2 over 36. And that's 8 over 36. let's see, let's take the 4s out of there, and I'll have 2 9ths. Okay? Pretty good, huh? All right. So, now, sometimes what we do is we look at what's sometimes you'll hear referred to as empirical probability when we do surveys and such. We say, all right, how many people said yes to a question on a survey? And so there might be like 53 out of 100, say. That's just made up. And as that bottom number gets large, sometimes that we can use this proportion can really be approximated by the normal distribution. Aha, remember the normal distribution? Okay. So, what we've been doing in the earlier part of chapter 18, those are what we call discrete. Okay, we can count them. They're integer values. When we get to this point, when we approximate by the binomial, that falls into something that we call a continuous distribution. Now don't panic because of all these scary looking words. Okay? In that case, you don't count so much anymore. You're going to use that normal curve to get your probabilities, and you'll get your mean and your standard deviation and thing. Okay? And you can also get your probabilities just like we did before. All right, so let's look at the example. It starts on the bottom of page 427. And let me flip the page. They started with, is it 25, 27 adults? And asked them some question. How they define marriage. And the number that said yes. Okay. And they repeated that problem, or they repeated the sample 1,000 times. Okay. Oh, they didn't give us any numbers, but they did a sort of simulation. Okay. And if you look at the bottom of page 428, they give you that beautiful histogram with the density curve superimposed on it. So that's what gives you your normal curve. Okay. Now what they did is set you up with the p-value, the probability of 0.5, 0.50 on the nose, and they use your, where's that standard deviation? It's gone. Where did it go? Huh. Standard deviation of 0.01. Okay, and that's where they, excuse me, where they got their normal curve and the density curve. Okay. All right, so if you look at example 4 that starts at the bottom of page 429, this time they gave you a nice number with values and such. So they have p hat. Now, the p hat just means it's a sample. So they have 0.5. They have the sample standard deviation. Oh, they just gave the of 0.022, and I bet they have a lovely picture when they turn the page. Why, yes, they do. And then you can get your 68, 95, 97.5 rule, and you can get your probability statements. Okay, just like we were doing before. Nothing interesting. Okay, so the original ones, those are discrete. Here you can use R to get probability statements. You can do what you wish with those. Okay, good. Thanks.